Hello everyone, and it's been a while that I haven't posted any YouTube videos. So here I am. All right. The reason why I haven't posted any YouTube videos before because I was so busy that I was certifying myself as a tutor in Schoolhouse World. If you know Schoolhouse World, then good for you. But if you don't, I'll just give you the idea. It's basically a free tutoring website. So yeah, I've been certifying myself in that website for me to tutor others. And I think that will be all. That's all the thing that I would like to say. So let's now begin in answering true or false video about angle of elevation and depression. Forgive my background if it's messy, right? So just focus on the problem. Right, let me just fix my camera. There we go. So let's now begin. Angle of elevation and depression are about the increase and decrease of angles. Angle of elevation and depression are about the increase and decrease of angles. So, if your answer here is true, well, I think you need to watch my previous videos again, or you need to do some research because this is actually false. Why is it considered false? Because here, angle of elevation and depression are not about increasing and decreasing of angles. And if you want to have some visual aids, just assume that we have two rays, all right? And then the corners or between them, that's the angle. So if you meant increase, that means assume that we're just going to move this side. Like for example, let's rotate it even further. This is what happens. It rotates. It's like that. But when you say decrease, think of it this way. This is your original form of your angle, and then you move this part, you rotate it on that direction. As a result, there's a decrease of angle. So this is not actually about increasing or decreasing angles. All right. So next question. Angle of elevation is an angle that is above the horizontal line of sight, whereas the angle of depression is an angle that is below it. True or false? This is in fact true. Okay? This is in fact true because this one, angle of elevation, is in the angle that that is above the horizontal line of sight, which is actually the definition of what angle of elevation is. Or in other way, it's actually angle of inclination. So if this is the horizontal line of sight and then there is an angle formed here above the horizontal line of sight, that is what you call an angle of elevation. However, if it's below, like like this for instance, that is already an angle of depression. Okay? So yeah, I think that's basically the gist of what angle of elevation and depression are. Angle of elevation and depression are not the same in measure. Angle of elevation and angle of depression are not the same in measure. So here, we could say that this is true. Okay, we could say that this is true. But at the same time, we could say that it is false. Why? Because if you're going to take a look, all right, if you're going to take a look, if let's just say angle of elevation, right? So let's just say it's, this is the horizontal side, line of sight, and then we have the angle here, right? Now, what if I told you that in this scenario, why in this scenario where okay, this is the angle of elevation, all right? But then suddenly, I want to know the angle of depression here in this scenario. So the angle of depression would be not from here, but actually here. So suppose we have an imaginary line that is parallel to the horizontal line of sight, and then we will form an angle here. So this is your what? Angle of depression. And now, you see, if we encounter this type of scenario, here, the angle of elevation, wait, I'm fixing my mouse. Wait, hold on. The angle of elevation is congruent to the angle of depression. Or in other words, they both have the same in measure. Okay, they both have the same measure. However, in other cases, like for example, let's just say I have an angle of elevation here, all right? And then in at the same point, I have angle of depression here. So, wait, angle of elevation, depression. So does that mean that both of them are the same? The answer is no. It actually depends on the given, all right? But was there a given where they are always the same? Yes, and that is this scenario. So, in other words, the answer here is not true. Oh, wait, sorry. The answer here is not true. It's actually instead false. Because there is a chance that they will be in the same measure. Okay? There is a chance, just like this one. Okay? Because in this case or scenario I told you before or earlier, this way, both angles are congruent to each other. Okay? So, third problem is false. Okay? So let's begin. Or maybe I have to rephrase this problem. Maybe I should have just put are not always the same, right? Forgive me, are not always the same. Much better. Always the same, right? Okay, so next problem. Angle of elevation and depression is applicable to business mathematics. The answer here is false, right? It has it has wait, how can I say it in a proper way? Basically, it does not have something to do with business mathematics. Basically, it does not have something to do with that. Because in business mathematics, it's more often on business. Like maybe we're talking about mortgage, maybe we're talking about stocks, bonds, compound interest, and so on and so forth. But here, in angle of elevation depression is actually more applicable to engineering. It could be applicable to physics, trigonometry, of course, and others, but not in business mathematics. Of course, not also in economics and in law. All right? Mhm. And next problem, angle of elevation and depression is one of the most important applications. Sorry for the grammar. One of the most important applications of mathematics. The answer is yes. This is in fact true because um, these are like uh, applied in my case in engineering field because if I remember correctly, like there is a problem where we have to find a force, but then the force problem is that it's not horizontal force nor uh it's a vertical force, but rather it's a diagonal force. You know, like for example, this one. I have this force given, right? And then I have a given angle. So the thing is, I have to find the resultant components. All right. So basically, I've wait, no, not resultant component. I am going to find the components of this force. To be particular, the horizontal component of the force and the vertical component. So I'm looking for it. So of course, I need angle of elevation for that. And depression in case if the the given force it looks like this instead, right? So yeah, and I think it's not also in engineering but also in physics, especially the fact that I talk about right finding the components of the force. It has also something to do with vectors. Okay, especially that I've given you some real life applications about angle of elevation depression that even makes sense because right now I'm giving you the examples from the subjects or course like from engineering and physics, but right now I can give you some of the important applications of it, like for example, if you're going to let's just say if you're going to have a ladder on on a wall, and then you have a ground here, and then let's just say that you have a given angle at this point. Now the thing is, suppose the distance between the bottom and to the wall, let's just say it's 4 meters, and you want to find this one, and then you have a given angle here. All right. So here you can apply angle of elevation in this case. Okay. Or if you want to apply angle of depression, you can, but the angle would be here instead. Right. The angle of depression would be here instead. All right. So I think that will be all. Let me take a look. Yes, that will be all. So our next video is more on problem solving. All right. So that will be all, and see you guys soon.